Welcome to the second part of 8.3. So we talked about how to simplify. Now we're going to talk about adding and subtracting radicals. So let's start with an example. Here I want to add these. Notice the radicals because they both have a square root of 13. If they both have a square root of 13, can I technically factor out the square root of 13? Yeah, we can factor it out. What would I be left with? Well, this first term, if I divide that by 13, the square root of 13, obviously that goes away. I'm just left with 8, and here I get a 2. Well, 8 plus 2 is 10, so it's 10 square root of 13. If you think about that, it's the exact same idea if I had 8x plus 2x would be 10x. The only thing is instead of x, I have a square root. So we're allowed to do this as long as the square roots are exactly the same thing, or if they're cube roots that are exactly the same thing. They have to be cube roots or square roots or nth roots that are exactly the same. And then I can just add the numbers on the outside. So let's try this one. Notice they all have the same, it's called radicand, the thing that's underneath the radical. They all have the same radicand, so I can actually just deal with the outside. So I want to pause the video and combine the outside terms. Well, as you did that, notice I can pull the 6y, I'm left with 19 plus 5 minus 10, which is 24 minus 10, or in other words, 14 square root of 6y. So adding and subtracting when we have the exact same radical is really nice. It's actually very, very simple. But what happens if we don't have the same radical? Ugh, now what? Well, it's actually not that bad. So the first thing we need to do is simplify them. So can you simplify? I want you to just pause the video and simplify the square root of 20 and the square root of 45 based on we've already done this section. Well, for the square root of 20, we can do a prime factorization. I get 2 times 2 times 5. And 45, I get 3 times 3 times 5. Well, what that means is I have 3, that's a 2, so it's 3, because this is really 3 times, so 3 times 2 times the square root of 5. This is 5 times, well, that's going to give me 3 square root of 5. 3 times 2 is 6, and then the square root of 5 is still there. And 5 times 3 is 15 square root of 5. So I simplified. Now notice, after I did the simplification, now I have the same square root. Oh, great. If I have the same square root, then I can combine them. And I can combine the outsides to get 21 square root of 5. So the key thing is if the radicals are not the same, we need to simplify first, and then we can combine like radicals. Let's try another one. Can you simplify these square roots? So go ahead and pause the video and simplify each of these 4 square roots. Go ahead. Welcome back. As you do that, you may have seen that 32 is 2 times 2 times 5 2's in x. 9 is 3 times 3. 50 is 5 times 5 times 2. And 16 is 4 2's. Well, remember looking for pairs. So this first one, I'm looking for pairs. So I'm going to get 2 pairs of 2, which is going to give me 4. And leftover is going to be 2x. Here, I have a pair of 3, so that's minus 3, and then that x just comes down. Here, I have a pair of 5's, that comes and the 2x is left over. And here I have 2 pairs of 2's, so again I get 4 for that minus, and I get just the x left over. So that is how we simplified. So that's just practicing even what we did earlier in this section. Now, which of these can I even combine? Because remember, we have to have the exact same radical to combine them. Well, hopefully you're saying I have the 2x, the square root of 2x, those two, and the square root of x's. So I can rearrange them like so. So I just moved them around, kept the minuses and pluses as they were. And now that they're in this form, I can just say, okay, what are these two? So I have 4 square root of 2x and 5 square root of 2x, which is going to give me 9 square root of 2x. And minus 3 minus 4 is minus 7 square root of x. So hopefully you're seeing the trend here is I need to simplify and then we can combine. So there's 2 parts of it. Make sure you keep it all straight. All right, I want you to try it again, but this time let's do it with a cube root. So again, simplify and then combine all together. Go ahead. Welcome back. Hopefully as you did this, you first off realized that 54 is 2 times 3 times 3. A to the 5th power is a cubed times a squared, because remember we're looking for multiples of 3. B to the 6, well that's a multiple of 3, so I can just leave it right there. Now, now this, I have the AB, sorry, my computer's acting weird with my program. 16 breaks up that way. A squared is a multiple of 3, is not a multiple of 3, but it's smaller, so I can't break it up into some multiple of 3. So I'm just going to leave it. And then that b cubed, well, that's a perfect number as well. All right, now if we take this, the perfect cube there is 3. A cubed, I divide that by 3, and I'm going to get an A. And then b cubed is going to give me b squared. And underneath the cube root, I'm left with 2 and a squared. I apologize, it keeps showing you everything else. It's okay. This isn't like a magic trick. Here, I have AB times 2, because I remember 3 2's. Well, then I have a squared. No, I can't divide that, but I can divide this by 3. So 3 divided by 3 is going to give me a b. And left over, if I took 3 of the 2's, I only left with 2a squared, because those are the only things I did not use. Now, if I multiply this real quickly, we notice I end up with 2ab squared, because b times b is b squared. Now, if you look again, this is where it gets interesting. So I have the same radicands. That's really nice. But also important is these are to the exact same thing. So if I just took everything except the numbers away, the variable and the square root are exactly the same. So I can just combine the numbers, which would give me 5ab squared times the cube root of 2a squared. So this whole process is just a matter of kind of looking at it and trying to see how things fit together to really understand better how we can utilize everything. I hope this helps. Let me know what questions you have, and good luck.